Hello everyone. We are going to discuss about the linting with Verilator, which is one of the open source tools for Verilog and system Verilog compilation. And it is well known that Verilator provides other options also, like for clock domain crossing and linting, right? This is an attempt to understand how to install Verilator tool in WSL platform, that is Windows subsystem for Linux platform, or through Docker platform. Basically, let us try to understand how to install this tool and then experiment a few linting exercises. And of course, most of the industrial tools of linting are based on either Cadence or Synopsys, like Jasper Gold or Spyglass tools. But so from the open source perspective, Verilator is also a little bit good in providing various linting cases, and let us try to explore how Verilator is effective in handling the the various linting cases. I'll first start with Verilator Docker image installation in Windows. Okay, so first you need to have a Docker installed on your machine. Okay, Docker desktop should be present in your machine. Ensure that Docker desktop is present, and then make it on. Okay, so open the Docker desktop. So the Docker desktop will be something like this. So you can use this for installing your other Dockers which are required for various purposes. Now, once you ensure that the Docker is present in your machine, then you can either open PowerShell or command window, command prompt to install like this: Docker pull Verilator slash Verilator. All are in small case. Okay, Docker pull Verilator slash Verilator. So this will pull the Verilator image. Okay, there are other ways to install the Verilator, right? WSL is different purpose, follows a different approach, but from the Docker perspective it is well and good. Okay, because even we have Icarus Docker images available. Something similarly, Verilator also has the Docker image of Verilator is also available. So this is one of the best approaches, I feel. Docker pull Verilator slash Verilator. So what will happen is that image will be pulled. Okay, so that will be stored permanently in your Docker. So whenever we want to run that, we can run with that. So Docker pull Verilator slash Verilator is the first step. And the logs, I have presented the logs during the process of pulling the Verilator Docker image. Okay, so you have finally it will say that downloaded newer image for Verilator slash Verilator latest. Okay, it's a very latest image that shows that the very latest Docker image for Verilator has been downloaded. And after that, you can, if you want to run that, you have to use Docker run hyphen it Verilator slash Verilator. So in that case, after this, you have to run that. You have to give the path of your file, what RTL file you want to give, or whether you want to do any clock domain crossing related exercises, or whether you want to do linting oriented exercises. In fact, there are many arguments, more than 30-40 different arguments that are supported by this Verilator tool that we can you can explore whenever you want to use them. So this is a Verilator Docker image structure. Okay, so in the Docker image, Docker desktop, you can open it and type Verilator, so that that will show you whether the Verilator is present or not. So here it shows that the Verilator is present. Verilator Docker image is present. So here the Docker image has been pulled using Docker pull Verilator slash Verilator, and after that Docker run it we can use Docker run command, we can use it, but later we can try to use this. So this shows that the Verilator Docker image has been installed in the machine. And then this is very later installation in WSL. So basically what we are understanding is for installation of Verilator with Docker desktop, we can install using Docker pull Verilator / Verilator, and Docker run can be used to run examples using the Verilator image. Then Verilator Docker image can be checked using this. Once you open the Docker desktop and if you type Verilator, it will show you whether the image is really present or not. And Verilator installation in WSL, that is Windows Subsystem for Linux. Okay, so here what you have to do is after going to the PowerShell, you can type WSL. Okay, WSL hyphen Ubuntu or something like that. You can simply type WSL, but WSL should have been installed in the machine, then only it will work. Okay, so ensure that Windows Subsystem for Linux has been installed in your machine. Okay, so I am explaining this example based on Windows OS only. WSL. Okay, so once it opens up the WSL, you can go and type sudo apt install Verilator. Sudo apt install Verilator. This should be done inside the PowerShell. Maybe inside the PowerShell. Open up WSL and then try to install sudo apt install Verilator. Sudo apt, it will ask for the password and it will open up the operating system. Okay, it will open up Linux operating system because it's Windows Subsystem for Linux, right? So it will open up Ubuntu operating system in this case. Okay, it says welcome to Ubuntu 24.04.2 LTS. Okay, so we are now inside the Linux Ubuntu OS, and now we are installing sudo apt install Verilator. One approach is using the Docker image. We can use Docker pull Verilator / Verilator. That is approach one. And if you want to, that will run completely the CLI based on Windows platform, especially on the command line prompt oriented commands you are going to give there. That's completely on Windows oriented commands. But now WSL, you are going to install the Verilator inside the Linux OS. So therefore, the running is also going to be based on Linux OS. Okay. So either way you can try to follow, whichever way you prefer, whichever is suitable. You can, if you have already Docker installed on your machine, the former approach is better. Or if you have WSL installed, the later approach is better. There is no difference in evaluation of Verilator outputs, especially for linting based on the operating system. It's going to judge based on your RTL file only. Goals of linting process. So what the linting process does is, linting process ensures that whether the design is free from any of the unnecessary errors, basically. Okay, so it checks basic connectivity issues in the design, such as floating point input, width mismatch. Okay, it's not going to be focused on functional error. It's not going to evaluate whether the design is different from your spec, but internally from the code wise, it is going to check whether you are not using any signals, or whether you are not writing any default cases, or whether you are not using any bits of the signal. Right, these are some examples. Whether you are using synchronous and asynchronous reset in the design, and whether you are using different polarities for the resets. These are some examples. These things are coming under the linting errors. Okay, incomplete sensitivity list, incorrect use of blocking and non-blocking assignments, potential functional errors, possible simulation hang issues. Right, this goal identifies the structural issues in the design that affect the post implementation functionality. Okay, we all know the common linting issues, but let us try to understand how open source Verilator tries to capture those linting errors in the design. Some typical lint targets are unsynthesizable constructs, unintentional latches, unused declarations, multiple driver and undriven signals. These common these short explanations are sufficient to understand. I need not explain these things very well. Okay, from the bullet point itself, it is understood that what it means. Race conditions, then incorrect usage of blocking and non-blocking assignments, out of range indexing. So these are some examples which are classified under linting errors. Now let me get into the execution of linting process with Docker. Okay, that is my approach one. Okay, I'm going to explain. I'm going to run the linting based on both approaches. My former approach was based on Docker image approach. So second approach is based on the WSL approach. This is a command docker run -rm-v. So now what you have to do is you have to go to the directory which contains the RTL files for which the linting has to be checked. You have to reach the particular directory which houses the RTL files, which comprises all the RTL files for which the linting has to be executed. Now docker, go to the directory and now run docker run -rm-v, double quote, inside double quote %cd percentage :/work. That means that it is going to prepare your file in a work directory, in /work directory, and then locally it will be taken to the work directory and the execution will happen. That is the meaning here. Okay, actual command we are interested is docker run is the main command that we have to use. Docker pull we used. Okay, so docker pull is for pulling the Verilator image. Now docker run is for running the linting example. Docker run -rm-v, double quote, inside double quote %cd :/work, double quote gets over, -w/work. After that Verilator, because the image is called Verilator/Verilator. Okay, the image is called Verilator/Verilator. But in the case of WSL, it is called Verilator only because we install sudo apt install Verilator. But in the Docker image, it should be Verilator/Verilator. And after that, the Verilator provides us various commands. Okay, you can check that with the -help, but I am going to use it only for the linting purpose. Okay, -lint -only -w all. W all stands for warning. Okay, all the warnings it will display. Okay, all the W error, W no error, like that. There are different command line arguments available, right? -lint -only -w all. After that, -sv, that represents the system verilog or verilog file. Okay, -sv. After that, the file name. So here this example shows one log, right? Verification, Verilation report, Verilator. So this means that the particular file is free from any linting error, or it has some particular structure in which the linting tool is not able to distinguish that this is correct or this is a linting error. Okay, meaning that this particular file does not have any linting error that are captured by the linting tool. Okay, this is how we are going to run that inside the Docker image. Okay, then coming to the running lint in WSL. Okay, running lint in WSL, that is Verilator -lint -only -w all -sv. Okay, so lint only -w all -sv -sv lint, both this particular command structure is same for both Docker image command and WSL command. Only thing is, there inside the Docker what we are using is docker run, and after that we are giving some /work directory to set up the execution in the work directory internally, and then Verilator we are having. Here in WSL, this is for the Docker execution. Inside WSL, what we are having is Verilator /lint -only -w all, sorry, -lint -only -w all -sv, and then file name. Okay, this is how we are going to run that in the WSL. Okay, now before getting into example, I will go to the command prompt. Okay, this is a command prompt. So I'm in the particular directory which comprises my Verilog codes. Okay, so this is how I am running it. You can see this Docker run hyphen hyphen rm hyphen v cd percentage cd percentage colon slash work. So this should be in double quote hyphen w slash work Verilator slash Verilator hyphen hyphen lint hyphen only hyphen w all hyphen hyphen sv. After that the file name. Okay, so this does not have any linting error in fact. So this is the actual file. Okay, some tools expect C to be declared as a wire. Okay, C to be declared as wire. But this is correct only. Assign C equal to A plus B. This is a continuous assignment statement. Okay, input A comma B, output C. It is given. It is not mandatory. Most of the tools accept this because if it is a behavioral model, if it uses any always block or initial or something like that, then we may expect that should be the ridge should be present. But here this error is not a really linting error actually. This error, there is no error in fact in this particular code. Now moving on to the second code. Okay, I have some examples. Okay, the second code. Okay, I have kept the entire command as it is, but changed the last file name only. Okay, it was ex underscore 1 earlier. Now it has become ex underscore 2. Now look at the log here. There is a difference between this log and this log, right? Because this log shows that there is no linting error in the code, but this log shows that there is something wrong in the code. So it shows the warnings. Okay, it shows some warnings. Okay, the warnings are coming because of this W all. Okay, let us try to remove this and try to test what is happening here. Okay, it's not showing any warning. In fact, if you can observe. Okay, so after lint only, try to add this W all. So some of them are warnings only. Okay, error means like it's not going to. It may affect the performance of the design, but not always the linting errors can affect the performance because in few cases it may create unintentional latches. Okay, they are not completely different from the behavior. They are not complete deviation from the behavior. Sometimes based on the case. Okay. So warning case like so it says lint in the third line missing new line at the end of the file. Okay, suggest to add the new line. That's okay. For warning description, okay, that is now what is our interest is like lint exe underscore 2 first line bits of signals are not used enough to bits of signals are not used enough to. Okay, so what they are saying is in is the input, the enough 1 and enough 0 have been used, but enough has been used but enough 2 has not been used. That is the actual error. That is a linting error. Let us go and see the code. In fact here, yeah, let's see the code. So here it says module. Okay, module lint in output is a 2-bit, input is a 3-bit. Assign out equal to enough 1 colon 0. So what happens to the enough 2? We are not using it, right? So that is what is shown in the linting error by Verilator. So Verilator shows that this is not shown. I mean, this is the Verilator shows that enough 2 has not been used. That's why it has captured that this is a possible linting error. In fact, it is correct only because in the code we are not using enough 2, we are using only enough 1 colon 0. Okay. So Verilator has correctly captured the linting error. Okay, unused signals. This is comes under the category of unused signals. Now let me go to the PowerShell. Okay, so here let us try to examine how WSL helps us in evaluating the the linting with Verilator. So just type WSL. Okay. So Windows subsystem for Linux should have been installed in the machine. Then only we can go here. So here I'll move to the directory. Right. Okay. So here we are moving on to this particular directory and this particular directory. And here, as I already told you, you have to use sudo apt install Verilator. Sudo apt install Verilator. I have already installed the Verilator, so just it will show that the Verilator is already there. Verilator is the newest version 5.0.5.020-1. Okay. If you look at this example, yeah. So here hyphen version. Here also in the Docker image also it shows that Verilator is 5.0.0. 5.0.40. That's a version of Verilator. Here also it says 5.020-1. It's a new version. You can also test that with Verilator hyphen version. Verilator hyphen version. So Debian OS. Okay. So it shows it's a WSL. Okay. Okay. All right. Now let me run the one small code here. Okay. So the same command I'm going to use. There docker run I have to use. Here directly I can use because this is a Linux command. Verilator hyphen lint hyphen only hyphen wall hyphen sv lint underscore exe underscore 1 dot v. Okay, so now it's not showing anything because there is no linting error in the example 1. Let us go to the example 2. Okay, the example 2. So the example 2, as we already know, it uses 3-bit input and 2-bit output. For the 2-bit output, last 2 bits of the inputs have been assigned through a continuous assignment statement. We have assign out equal to in of 1:0, but we did not use the in of 2. We were not using in of 2 in the code actually. So that is why it shows that bits of signal are not used. In of 2 has not been used. So exiting due to 2 warnings. Exactly what we have to understand here is exactly the same error log was reported by the the Verilator Docker image also, and the same log can be found through the WSL Verilator also. So obviously we have to understand that there is no difference in the logs produced by the Verilator in the Docker image platform or in the WSL platform. Okay, so that is pretty clear. Now I have some more examples. Okay, so now we understood how to install Verilator using Docker image, how to install Verilator using the WSL, and how to execute the examples also. So let me now get back to some examples, um, some logs that are produced by the Verilator. So let us examine that. So all the examples that I am going to present now are based on WSL, Verilator and WSL. So example 3 is missing cases. Okay. So we have case 2B00, 2B01, 2B11. So there is no 2B10 case. Okay. There is no 2B10 case. And then default case also. Case is missing. Okay. It shows that two things. Signal is not driven. It is giving two errors. Signal is not driven. Mem is not driven. So okay, mem of 0, mem of 1, mem of 2 we are using. Okay, mem of 3 we are using. But we are not using mem of 1. Okay, that is one mistake. And another case is In the line number 5, okay, case value is incompletely covered. Example pattern 0x2. Okay, that means 0 1 0, 2b 0, 2b10, 2b10 has not been covered. So two linting errors it has captured. Verilator has captured. So this is running with the this log is based on the WSL. Example 4, using different reset polarities. Using different reset polarities. Now you see the reset. First reset is passage reset. Second reset is neckage reset. Both are asynchronous resets. Okay. Active low and active high. So different reset polarities. Okay. So it's showing that use lint of new line. So it is producing some particular error. Okay. Suggests a no line kind of thing. This is what it has shown actually. It's not really showing where the particular reset oriented error is there. Okay, this is one particular difference that we have to understand from this particular example. Now example 5, using sync and asynchronous resets. First example uses asynchronous reset. Second, first always block uses asynchronous reset. Second always block uses synchronous reset. So now it says signal flopped as both synchronous and async reset. Okay, location of async usage. Fourth line, location of async usage. Okay, and line number 11. Yeah, 11 it shows that location of synchronous usage. So first is asynchronous reset. Second one is synchronous reset. So basic error is signal flopped as both synchronous and asynchronous reset. So it has captured that clearly. But here I don't see any mismatch, like, because one is the polarity is different. Okay. Now moving into module driven by both edges of the clock. First always block passage clock. Second is based on neckage of the clock. Okay. Now if you run that on example 6. Okay, so example 6, if you run here, so example 6, okay, it's not deliberate, exclusively showing that this is having a particular error as the module is driven by both edges of the clocks. Okay, let us try to analyze where the verilator is really performing well. Example 7, net is not driven. Okay, net is not driven. So here, so we have 3-bit net. Okay, 3-bit net. So let us see what it does. Logical operator log and expects 1 bit on the LHS. Okay, out one is 1 bit, in one is 3-bit, and the net are 3-bit. So what it is exactly telling, logical operator log logical and expects 1 bit on the LHS, but LHS in one generates 3 bits. That is really wrong. Okay, we are ending with 3 bits. We are working on 3 bits to produce output bit 1. Similarly, logical and expects 1 bit on RHS, but RHS net generates 3 bits. Okay, that is also wrong. Signal is not driven. Net is not driven. Net is not driven. So that is also, so it has captured all the required linting errors. Next is truncation of extra bits. Truncation of extra bits. Now out one is a single bit data. Okay, it's a single bit output, but we are assuming 4 bits to that. Too many digits for 1 bit number. Too many digits for 1 bit number. Similarly, too many digits for 2-bit number also. That is also wrong. Out one you have to take only 1b1 or 1b0, but we are keeping 1b1011. And then say if out one equal to 2b0101, there also for 4 bits, for 2-bit value we are keeping 4 bits. That is also wrong. So it is exactly capturing the linting error. Too many digits for 2-bit number, too many digits for 1-bit number. Okay, so it has captured the two linting errors. Next is blocking assignment should not be used. blocking assignment should not be used. Inside always block, it is always advised that whenever you are using a procedural block, we have to design the system based on non-blocking assignment operator only and not the blocking assignment operator. It's a mistake, linting error. So it exactly captures the mistake. Blocking assignment equal to in sequential logic process, suggest using delayed assignment less than or equal to. So blocking assignment is not going to produce your circuit properly, because it will block the execution of other things that will create some kind of asynchronous operation, some kind of undesirable operations when you are trying to execute the circuit. So basically a good design practice, a good sequential design practice should be based only on non-blocking assignment operator, and there is no place for blocking assignment operator in the RTL, especially if you try to design sequential circuits. So it has reiterated that, and it has also captured the line of that Q equal to D in, right? So this, so the Verilator tool is capable of capturing this particular linting error also. Next example, though else will produce a latch. Okay. Yeah, this shows that one particular warning here. Okay. So if not reset, if reset equal to 0, Q equal to this, what will happen else? This will produce a latch. This will produce a latch, but this particular argument, okay, it's not capable of detecting it. Actually, it's not showing anything on that, but it says that some warning is there. Some warning is there. Okay, and it's not explicitly saying that there is no else case in this. So this may lead to potential latch, like that. It's not saying from the logs that I am observing. Next is initial statement not synthesizable. Initial statement not synthesizable. Okay, and if you see this, there are multiple errors, multiple linting errors. We are using a we have declared a clock in this, but we are not using it, so it is capturing that. Signal is not used, clock. Signal is not used, that is correct. Second one, non-blocking assignment less than equal to in initial final block. Basically initial we will be using only blocking assignment. Okay, so it says that you should not use that. And then non-blocking assignment in initial final block. Oh, there are two non-blocking assignment statement, but it says that it should be executed, should be used as a blocking assignment. Okay, it does not say anything about whether synthesizable or not, but it is not advisable that RTL design which executes your DUT, it is also advisable that RTL design should not have the initial block. It should be based on only always FF, always latch, always comp. So this is the last example. Undriven signal in instantiation. Undriven signal in instantiation. For example, if you can see the instantiation half adder, there is no signals mapped to B, sum, right? B and sum. So let us see what the Verilator executes. File name does not match module name HA. Okay, so that is one thing. Cell pin connected by name with empty reference B. So it has captured. So and it has indicated also. B, signal B has not been mapped. Okay, one thing is you need not map anything, but if you write there with the empty mapping, then it will be definitely captured as an error. Similarly, it is capturing no mapping for B, no mapping for sum. So these are the expected linting errors, and Verilator is doing well on that front. Signal is not used B. Okay, so we have declared it, but mapping has not been done. That is also one error. B also we have done, sum also we have declared. So signal is not used B, signal is not driven sum. Okay, some output. If it is input, it says that it is not used. If it is output, it says that it is not driven. Okay, so in this particular discussion, I was focusing on how to install Verilator on Windows platform, either using Windows subscription for Linux or installation using a Docker image, and then we executed some examples. Hope this helps you to explore this open source Verilator for running the linting examples. Thank you.